Now that we know how to determine whether or not something is a function, we want to be able to evaluate the function at particular values. So this is a picture of what we call the function machine. Remember that when I have a function, I have an input, which we would consider the x values, that's put into the function machine, evaluated, and it spits out the output, which is my y value. Now the function machine is represented by an equation that we are looking at. And when we put a value in for x, evaluate the equation at x, we get a y value. Now we are introducing a function notation here where we say f of x, which means it's the value of the function at the number x. These two representations, whether we say y equals or f of x equals, mean the same thing. And we will be using function notation for a lot of equations. So let's go down here and let's look at a couple of examples together evaluating this particular function for given values, and we want to simplify it. So the first one we're going to look at over here, for example A, I want to evaluate the function g at -1. My function g of x is given up here. So when I evaluate the function at -1, it simply means that I'm going to be replacing my x variable with the number -1. So I'm going to say -1 squared because my first term, my x value, is squared. I'm going to surround my -1 with parentheses and then put a square up there. Minus 10 times -1 minus 3. So you notice that this right here is my x value, this right here is my other x value in my equation, and I'm simply going to simplify from here. -1 squared is just 1. -10 times a -1 is a +10, and -3 or minus 3. So I have 1 plus 10, which is 11, minus 3 gives me 8. It's very important, so a word of caution, whenever you're evaluating functions, to surround the number you're evaluating with parentheses. I can't tell you the number of times students will just put in -1 squared like this, and if they were to put that whole string right there in their calculator, the calculator would not return back a +1 like it was supposed to be. Instead, it would only square the 1 and then multiply it by a negative. So parentheses are very important. Let's evaluate my equation g of x, or my function g of x, at x plus 2 this time. So when I do that, I know I'm going to replace the x values with x plus 2. So I like to go in here, I'm going to put a large set of parentheses representing my first term, which is squared, minus 10 times something, make that a little smaller, minus 3. Now, what goes in the parentheses is this x plus 2. So I have x plus 2 here and an x plus 2 here. And now I know what I am evaluating. So the first binomial that's being squared, we're going to practice our square the first, double the product, square the last again. So this is the first term squared. So we square the first, x squared. We double the product, that would be 2x times 2, or 2x double would be 4x, and we square the last, plus 4. I've done that on previous videos if you don't remember. Now we're going to take this -10 and I'm going to distribute the -10 inside of the parentheses to remove them. So I have -10 times x is a -10x, -10 times 2 is a negative, not positive, is a -20. And I have a -3 or a -3 over here. So from here I've removed all of the parentheses, I've squared what I'm supposed to square, and I can collect my like terms. Starting with x squared, and then I move on to the x's. I have a plus 4x minus 10x, so I have minus 6x, so the x's are gone. And I have a 4 minus a 20 minus a 3, giving me 19, or minus 19. So this is the simplified version of evaluating the function g of x at x plus 2, and that's your solution. The last one we want to look at is right here. I want to evaluate I want to evaluate my function at g of negative x. So if you remember, let's see, here it is up here, we'll make it a little smaller. If you remember, we have my first term squared minus 10 times that x minus 3. So everywhere I have a parentheses, I'm going to replace that with a negative x and simplify. What happens when I take negative x and square it? I get x squared. Negative 10 times a negative x is a positive 10x, and minus 3. So that was evaluating the function g of x at negative x.